All right, find the average value of the function over the given interval. Since I did the last one graphically, I'll do this one by hand. Again, by hand is probably a little better because you're less likely to have a rounding error. So my function is 2e to the x. I want to find its average value from negative 3 to 2. So negative 3 would be my a, 2 would be my b. So my average would be 1 over 2 minus negative 3, integrating from negative 3 to 2 to e to the x with respect to x. And so this simplifies to 1/5, integrating. All right, so I'm going to solve this one by hand. I'm not going to solve it graphically. Can't forget the 1/5. Don't forget the 1/5. So 1/5 times the definite integral, which this one's not too bad, right? The antiderivative of 2e to the x is 2e to the x, and then I have to remember to take care of negative 3 and 2. So again, I'm solving 1/5 times the antiderivative of 2e to the x, but I've got to plug in my lower value 3 and my upper value negative 3. So this would be the notation we use to indicate my next step. So 1/5 times, well, when I plug 2 in, I'm going to get 2e to the second minus plugging negative 3 in, which is 2e to the negative 3. That's exactly what the average value is. That's exactly what it is. So the average value of this function from negative 3 to 2 is exactly 1/5 times 2e to the second minus 2e to the negative 3, and then you can multiply that out on your calculator. Make sure I multiply it out carefully. So we get 2e squared minus 2e to the negative 3 divided by 4 comes out 2.9357 is the average value. So is approximately the average value of f of x from negative 3 to 2. Alright, so on average, now sometimes it's bigger than that, sometimes it's smaller than that, at least one time it's the same as that. But when we average all of the function values between negative 3 and 2, it comes out to be almost 3, 2.9357. Alright, applications, which the first application is very similar to the last example. So suppose that we have a concentration of drug in a patient's bloodstream. Alright, so they've got IV or something in. It's measured in milligrams per liter, t minutes after the drug was injected. Alright, so it's injected, so it's a shot or something. F of t equals 8e to the... So again, your body breaks it down, right? Breaks it down and it eventually comes out as waste. How much of the drug is in the bloodstream initially? Find the average concentration of the blood in the bloodstream from 5 to 10 minutes. Alright, so A is algebra question, right? So make sure, again, be careful. This is just an algebra question. It's just how much is in the bloodstream initially means at time 0, right? When they inject you with the drug. So this is just finding f of 0. So 8e to the 0. 8 milligrams per liter is the initial amount in the bloodstream. Alright, so you have 8 milligrams per liter of blood, right, in your bloodstream. B is the new thing. I want to find the average concentration. So I want to find the average function value, right? The function represents the concentration from 5 to 10 minutes. And so 5 would be my A, 10 would be my B. So the average value is the distance. We're going 5 minutes, but we're specifically going the 5 minutes, 5 to 10. Alright, so it'd be 10 minus 5, integrating from 5 to 10 of my function. And so again, I'm going to solve this one by hand. So this is 1/5, integrating 5, 10, 8e to the negative 0.05t with respect to t. Alright, so 1/5 times. The antiderivative would be 8e to the negative 0.05t. Divide by negative 0.05. And it should be negative. The body breaks it down. The drug is decreasing from 5 to 10. Alright, then I plug in my 5 and my 10. Which I might rewrite that 8 divided by my negative 5 as a proper fraction. Or as, again, a proper number, which is negative 160. So negative 160e to the 0.05 times 10. So that's negative 1/2 minus 160. Negative 160, so actually plus 160. E to the negative 0.25. And then the approximate number. When I write, that's exactly what it is. It comes out sure to type it in carefully. 5.5. 1, 2 milligrams per liter. Alright, so again, that's its average. Sometimes it's bigger than that, sometimes it's less than that. That's the average amount of drug in the blood per liter from 5 to 10 minutes. Alright, so on average. Has 5.512 milligrams per liter from 5 to 10 minutes. Alright, we'll stop there. Do the last two examples on my next video.